What's up, guys? Final exam guys back here, and I'm gonna do with you guys 10 solve limit problems. It's gonna be awesome, fun, and you guys are gonna retain all this information and do awesome on your exams. So don't forget, before we start, don't forget to check out my final exam walkthroughs. I've posted a few for Calculus 1 and 2, a complete exam solved and explained by me. So I'll put a link in the description. Or you can just find it on my channel. And also don't forget to subscribe so you don't miss out on any of my knowledgeable videos. Alright, let's get started. So question 1 says we take the limit as u approaches 5 of u squared minus 25 over u minus 5. So first thing to do is plug in your approaching value and see what happens. In doing that, we get 0 over 0. Bad. We got to manipulate this original expression so that we can actually get an actual number. So if we can, you see that the numerator looks very factorable. So if we go ahead and factor it out, it changes to u minus 5, u plus 5, and over u minus 5. So now we can cancel this out, and if we actually plug in our limit now, we get a real number 10. Alright, so the next question, we have the limit as x approaches 1 of x cubed minus 1 over x minus 1. So if you try to plug in 1 here, you still get 0 over 0, which is bad as well. So if we look at the numerator, it's easily factorable. So we get limit as x approaches 1. The numerator factors to this easily. So that's what we want to do in these types of limits. You just want to factor and cancel something out so that you can easily plug in your approaching value and get a real number. So if I plug in 1 here, I just get simply 3. Alright, so question 3 says the limit as u approaches 0 of 5u squared minus 4 over u plus 1. So we plug in our limit here. 5 times 0 is 0, so we're left with negative 4 over 1, so we actually got a number right away. That's pretty awesome. Let's go to the next question. Now this next one is a little fun, in quotations, fun, which just means it's a little longer. So we got the root of x plus 3 minus root 3 over x. So if I plug in 0, I'll get root 3 minus root 3, so 0 over 0. That's bad. So in math, we do not like having roots in the numerator. We always want to get rid of them. So we do something known as complex conjugate multiplication. So I'll multiply our expression by the complex conjugate of the numerator. So it becomes x plus 3 plus, so we reverse the sign of the second term, and we multiply the same thing on the denominator. Alright, so in doing that, it's basically FOIL from these two top terms. FOIL multiplication, and if you try it out yourself, you'll get x plus 3 minus 3 over x, open bracket, root x plus 3 plus root 3. Easy as pie. Now if we plug in our 0, we will actually get an actual number now. We'll get 1. Well, we can simplify this further. to that. And now if we plug in 1 or 0, limit as x approaches 0, we'll get 1 over 2 root 3. We got a real number, yay! Alright, so the next problem says that the limit as x approaches 2, open bracket, 1 over x minus 2 minus 1 over x squared, 4 over x squared minus 4. Looks a little messy, huh? So if we plug in our 2, we see that the expression becomes 1 over 0 minus 4 over 0. So anything over 0 is bad as well. We have to manipulate this somehow. We see easily here that there's a common term in both terms, which is 1 over x minus 2. If I pull out a 1 over x minus 2 from the both terms, I'll get 1 minus 4 over x plus 2. You can easily see that if you multiply this inside, you'll get back this over here. Alright, so if I try to get a common denominator here, so I'll make this denominator x plus 2, you'll get the following: x plus 2 minus 4 over x plus 2, which turns to 1 over x minus 2, x minus 2 over x plus 2. There, now I can cancel stuff out, right? This term. And now the limit as x approaches 2 of 1 over x plus 2 is 1 over 4. Phew. Alright, so question 6 says that the limit as x approaches infinity, that's positive infinity, of 2x 11 minus 5x 6 plus 3x squared plus 1. This one's not that obvious, but the trick here is to if you pull out the greatest exponent, you'll get 5. You'll see that 5 will be over some x, 3 will be over some x, and 1 will be over some x. And then if you plug in infinity, those terms will all go to 0. You'll see what I mean in a second. So say I pull out x11 here, what will happen? We'll be left with 2 minus 5 over x5 plus 3 over x9 plus 1 over x11. So now look what happens when you, and of course there's a limit as x approaches infinity here. So look what happens when I plug in infinity here. 5 over infinity is 5 over a really large number, so this term will go to 0. This term as well, and this term as well, so I'll get infinity times 2, which is a really, really large number, infinity. Alright guys, so the next problem is the limit x approaches infinity of 2x plus 5 over x squared minus 7x plus 3. So if you go ahead and try to plug in your infinity here, you won't be able to tell anything from it. I mean, it'll be infinity over infinity, but that's not a proper answer here. So we're going to apply what we did in number 6, except now it's a quotient, but it's still the same concept. Let's say I divide everything by the highest power. I would get the limit as x approaches infinity. I divide everything by x squared, so I'll get 2 by x plus 5 by x squared over 1 minus 7 by x plus 3 over x squared. And now you see that if I plug in infinity, this will go to 0, this will go to 0, this will go to 0, this will go to 0. I'll be just left with 0 over 1, so our limit is 0. Alright, here's another little tricky one. So limit as x approaches infinity of the root of x squared plus 5 over 3x squared minus 2. Alright, so if I try to plug in the limit, we get infinity over infinity again. So we got to manipulate this somehow. Let's apply what we did in 7. So divide by the highest power, and that's the one here right there, the x squared in the denominator. So we'll get the limit as x approaches infinity of, so if I'm going to put an x squared inside this root, I have to square it, so it'll be x4. So we'll have x squared plus 5 over x4, right? And then jot that better. Okay, and the denominator will have 3 minus 2 by x squared equals the limit as x approaches infinity. And so if I divide out this x4 with each term, I'll have, on the top I'll have a root 1 over x squared plus 5 over x4 all over 3 minus 2 by x squared. Alright, so plugging in infinity, this will go to 0, this will go to 0. So we'll have square root of 0 is 0, this will go to 0. So we'll have, again, a big fat 0. Alright, question 9 is a little fancier. We have a function, it's a piecewise function. Just want to introduce the notion of right hand and left hand limits. So we got a function consisting in piecewise 7x minus 2 if x is greater than or equal to 2. And if x is less than 2 for this one, it's asking us for the limit x approaches 2 from the right and the limit x approaches 2 from the left. So approaching from the right means we're coming on the graph, we have our line, we're coming this way. So we'd have to use a function, the piece of the piecewise function where the x is greater than 2, because we're greater than 2, we're coming from greater than 2, so we'll use the 7x minus 2. So the limit here would just be, you plug in your 2, you'd get 12, so that's that. And then obviously for the other side you're coming from the left, so you have to use the smaller x less than 2, so you get 3x plus 5. So you'll get 11. Not bad, huh? Alright. Alright guys, for the last problem we have this function 4x minus 5 over 3x plus 2. And it's asking us to find the vertical and horizontal asymptotes. An asymptote is just a line that the function gets closer and closer to, but it never actually touches. So let's say my function, there's a vertical asymptote here, my function will go, and then it'll skyrocket to like infinity, but it'll never touch the asymptote. Alright, so to find a vertical asymptote, we just set the denominator to 0. That's it. 3x plus 2 equals 0. So then x equals negative 2/3. And a horizontal line will be found by taking the limit of this function as x approaches infinity. 4x minus 5 over 3x plus 2. Now what we're going to do here is just divide everything by every term by x, which would make everything perfect. So we get 4 minus 5 over x over 3 plus 2 by x. These terms will go to 0, this term will go to 0, so we get 4 by 3. So the line y equals 4 by 3 is a horizontal asymptote. Well, that concludes the 10 solved problems. Guys, I hope you learned something. If you did, please subscribe to me and support me, because I'm going to continue making videos like this, and it's going to be awesome. Leave a like and comment down below if you didn't understand something or you want me to cover a specific topic. I will do that, no problem. So guys, good luck in your studies. I'll see you in the next video.